Yeah, we're live. Okay, hello everyone. This is first episode, first season, first episode of Postgres TV. I'm Nick Samokhvalov, and with me Ilya Kosmodemyansky. We usually do this. Hi, Ilya.
Hi everyone.
Yeah, we usually do this in Russian because we have quite strong Russian community around Postgres for many years. I started it in 2007, but right now I'm based in the US. Ilya is based in Germany, so we also talk. We professionally work with Postgres every day. We have our own small consulting companies and do some products, create some products. Ilya is from datagrid.com. I am from
Postgres.ai.
Postgres.ai, and we actually talk about Postgres in both languages. And actually, since a week ago we created this new episode about Postgres 13, and we enjoyed it because it was some kind of hands-on session. And we are going to repeat the same today in Russian, or in English, sorry. So first, I should say that Postgres 13 was released exactly 1 week ago, and Postgres major versions are released every year. And I'm going to share my screen and show you some pages where you can find information. And there are a lot of changes, right? And we discussed that there is a common opinion that there are no breakthrough features in this release, like big things, like some major affecting many people. But there are
there would be some things which affect many people, but there is no any just big single feature like it was
replication
or replication or something like this. It's a lot of small things, but overall it makes a picture of like a lot of changes actually.
Right, lots of changes. So usually, like if you watch some presentation or read some article, you never will see all of them, except maybe a document from Japan. I will show you shortly. Usually, people try to cover some features at some extent, and we will do the same, but we will try to show you some how it works, right, and express what we think about it, about new features, which we think which we think they are most interesting. And all features can be divided into some groups, and the most interesting groups are related to performance and observability, so monitoring. And before we start, let's where we gather information usually, except from the press release itself. Of course, Hubert Lubashevsky, I hope I pronounced it correctly, detach.com posts very beautiful pieces of he updates usually following when something is merged to master. He updates and also trying to show how it works, how each feature works. Then we have several articles, for example, from Jonathan Katz, Crunchy, quite good article with examples, so you can also see how it works, but it's very briefly covering several features. But this is very interesting document from Noriyoshi Shinoda. I'm sorry if I'm pronouncing it not correctly, from Hewlett-Packard Enterprise Japan, and it has 81 pages and very carefully observing maybe all of the changes that are noticeable for users, and this is very good information. So then we have also an article I will show you right now, which are from pgAnalyze. In their blog, we have this is a very beautiful article, and I like the fact that they already tried Postgres before release several months and have their own experience. And finally, I want to show you one more article which I also liked and explored only yesterday, despite of the fact that it's from Russia, actually. It's written in English, and quite good English, and you can see a lot of, let me remove this a lot of changes covered here with examples, and with quite good focus on performance. So this article was written back in May when Postgres was in beta, but I like this set of examples. Maybe it can be compared to this PDF document with 81 pages, but like fewer changes and maybe deeper, right? Few more interesting things. People already updating their tools, and not only tools, but some public services. And back to Detach, detach.com has a good service called Y Upgrade. You can choose versions, and if you, it's already supporting Postgres 13, so you can see how many changes Postgres 13 contains. And of course, it's not fair to compare 12 directly to 13 because 12 was also patched a lot. So maybe we should do this and see various changes between the latest minor version in branch 12 with 13. Also, this service I also discovered only recently. Interesting thing, you can see what kind of changes PostgreSQL.conf got in 13. And we see that we have new 14 new configuration options. And as I posted yesterday, if you go back 8 years back, during 8 years, PostgreSQL.conf got exactly 100 new PostgreSQL options, configuration options. Finally, this service...
It's kind of strange when you hit this from 9.2 to 13, updated only 17. It looks like slightly fishy.
Maybe it like what updated
it's about
means.
the method how they count this.
I didn't check it yet, so didn't check it yet, but this sounds quite reasonable. We know that PostgreSQL.conf has almost 300 options, right? So this is 1/3 of them appeared during last 8 years. It sounds reasonable to me, actually. Oh, by the way, I forgot to mention, you can interrupt if you joined Zoom. You can interrupt any time and ask questions. If you are on YouTube watching live, you please post chat questions. We are
we're monitoring that, and
yes.
yeah.
Okay, so finally, this service, if you don't know this service, it's also updated to support Postgres 13. For example, we know that log sampling was changed and got 2 new options. So you can see that this service helps you to understand PostgreSQL.conf options in more structured way than native documentation. And of course, it has all the information from official docs and more. It's quite handy tool, and you can see trace things which you can dynamically get from PG settings. Okay, that's actually it with overview of sources of information. Let's switch to hands-on session. Oh, I see a lot of people join Zoom. So hello, everyone.
Yeah.
So
we'll probably will have more interactive session today because of that.
Yeah, please ask questions anytime.
Cool.
It will be good if you ask. So I'm switching to my console window. Oh no, it was. Sorry. This is it. I hope you can see it. You can see it, right?
Yeah, it looks.
Yeah, good.
It looks okay.
Font size, okay, good. So this is how you can try Postgres very quickly. If you have Docker, it's just one liner, and it's already pulled. The image is already pulled here, so it's a little bit quicker. We need to wait a little bit and see how initdb is working, right? So in creating cluster, okay, database is ready to accept connections, so we can join it, connect to it. PG13, psql. Okay, we're here. It's actually release candidate 1, but we know that between release candidate 1 and release only 1 week passed. I know for sure that there are no changes there, and we will do the same for Postgres, for Postgres 12, right? Let's do the same to see, just to compare directly, right? Because changes between 12 and 13 are what we are interested in today. Okay, it was quick. So first change we will be talking about is probably the most interesting in terms of performance, right? It's about B3 index deduplication. Oops, sorry. If we what happened? Okay, sorry. So the first thing is B3 index deduplication. It affects everyone, right? So everyone is using B3. It's a default index. If we just create index by default, the type is B3. And Postgres 13 got very impressive optimization for all B3 indexes because of the work of 2 people, Anastasia Lubenikova and Peter Gigan. And I'm very excited because this work started, as I know, like 5 years ago by Anastasia, and it was very long path to release, right? And the idea is that normally, like very simply, normally many entries in Postgres are duplicates in leaves of the tree. And if you, it can be better optimized. And the idea came from gene indexes, which already had such kind of optimization. And Anastasia initially implemented this optimization. And I will provide link in this, actually it's already in this video, link to a very detailed technical talk from Scale conference. It's in English, so you can watch it, and it covers not only this optimization, but also other changes related to indexes Anastasia was and is working on. Some changes are for future, but some already in Postgres. So let's see how it works. We can create a table from generate series. Generate series is our best friend during some testing, right? Because we can generate a lot of rows. So we create a table. Let's do it both in Postgres 13 and Postgres 12. This was 12 and 13. And we will create index, some index on this integer column. Okay, so million rows, some index. And let's check, quick way to check table size and index size. So we see table is very small, 35 megs, and the index is 21 meg. This is as expected because, and like no difference between 12 and 13 here. And the index is somewhat less in size, smaller in size than table, right? So now let's do very quite silly thing. We will update this table all rows, right? Physically, Postgres doesn't care about logical change here. Logically, nothing changing because I equals I means we don't change anything. But physically, Postgres will generate new tuples for every row, and all tuples will be afterwards marked by AutoVacuum as delete. AutoVacuum will delete all tuples. So we will have basically quite bloated table and indexes. And let's check again. Table size, of course, is bloated roughly 2 times. We see it. almost 70 megs. In Postgres 12, it's also the same, absolutely the same, and index also the same. It's bloated. Not index, not the same, of course. So in Postgres 12, index is much bigger, right? So index is 64 megs. In Postgres 13, in newer version, it's much smaller, right? So it kind of in this silly full table update, index size increased 3 times in Postgres 12 and 2 times in Postgres 13. Of course, in real life scenario, pattern of updates or deletes will be very different. And as we see from articles, people report that index size is sometimes 3 times smaller in newer version. And this helps massively helps with performance, because the smaller index is, the better performance is, because less pages to fetch from, to read from disk and to fetch from memory and to work with. We usually notice when our indexes are bloated and we reindex them concurrently probably, or we apply PG repack, we see how CPU load drops and how disk space reduces, and like backups are happier because fewer bytes to backup, and the replication lags are under less risk, and so on. So this is very.
It would be very useful for example, Django users, because many people who use Django, for example, usually create lots of excessive indexes, like for each and every combination of roles. For those people, it would be like very useful feature if you do not forget to rebuild them after upgrade.
Yeah, very important. Of course, right. In any big project, there are a lot of indexes that are unused or like not suboptimal and redundant and so on. Of course, they are also will take less disk space. But very good comment. If we upgrade to Postgres 13, we need to rebuild indexes to get this new feature, and this is important because automatically you want. Of course, if we talk about upgrade using PG upgrade, if it's just smaller database and we did dump restore, or we did some logical update, new indexes will be created in new fashion already. Actually create index command has now a flag to control this. Let me find it. So you can control, and even in newer Postgres, you can, when you create index, you can say with options, deduplicate items of, should work if we give it another name, with just with, right? Yeah. So in this case, this index will be behaving as before without optimization. Let's drop it. So I also like why it's so good, because fewer duplicates in leaves of B3. We can actually quickly look at it. Extension with page inspect extension, which is very useful when we want to dive into internals and see how it looks like internally. So we can look at it with BT page and items. If we just do this, select BT B3 page items and say index is I1 and we want first page. Let's just directly compare how internally it's stored. First of all, noticeable that now we have more information returned by this function. And if we see, actually, it's already, yeah, it's already nothing. We need to update once again. Because I suspect that vacuum deleted all tubes. By the way, let's better alter system set auto vacuum. Let's do this. Don't do this on production, of course. I'm disabling auto vacuum. alter system, set auto vacuum off. Okay, and I'm going to start from the same position. Just when we vacuum table, indexes also will be vacuumed. So we starting from scratch and updating once again, just to see, to compare apples with apples. Okay, update. Okay, 12, 13. Take some time. So let's see how internally indexes look like. This is, no, sorry, write this. So we can see here that, interesting. So right. So this is CID. This is our pointer to heap. And we see here that 2 entries of bit3 pointing to the same CTID, right? This is 12. And in 13, we see only 1. This is already the main change here, right? And so we like using this, using page inspect, and if you want graphical mode, you can use also PG hex editor, hexedit from Peter Gagan. You can see it more in more graphical way. So this is how we can look at indexes and ensure that indeed in Postgres 13 we have optimized storage. That's why it takes much less space. Okay, any questions so far, maybe related to indexes? And like the main thing to remember when we perform PG upgrade, we need to rebuild indexes one after another using reindex concurrently or PG repack. But I think in 13 already we all need to switch to reindex concurrently. Okay, so next thing is actually interesting thing, also very good in terms of performance. If we talk about very wide tables, we know that Postgres splits the row into chunks and stores additional chunks in so-called toast table, right? And in this case, for example, if it's very huge, like it will take some time to create new table. I have it here. It's a table we repeat this million times, and we generate 100 rows. Let's do it. Let's create it. So in this case, we have main table, and the first chunk is stored there, but additional chunks go into toast. And before Postgres 13, if you, for example, need to read only few first bytes of it, of course, also there is some light compression applied to toast values. And before Postgres 13, if you read only first few bytes, Postgres will fetch whole value, decompress it, and only then apply, for example, substring, substar function. But it's very inefficient, of course, because we don't need all those bytes. We don't need only the beginning of value, for example. And right now, let's see very simple. This is Postgres 13, right? This is very simple query which tries to get first 10 values and then basically calculate it will be 10 and then summarize times 100 it will be 1000. And but physically we need to work with this value, which of course very toasted right now. And we can see here that in Postgres 12, even if we repeat it many times, it's around like between 15 and 30 milliseconds. But in Postgres 13, you can see it's around 1-2 milliseconds. And it's very good because this helps us to avoid spending more time for inefficient work. I also like this feature, which will be automatically available if you work with very wide, very big values, for example, some texts and so on. Okay, what's next? Let's talk about vacuum maybe, right?
Yeah, just we got a question in chat from Gabriel. The question is how fast is upgrading from 12 to 13 comparing to 11 to 12, considering this index rebuild? That question has
Good
actually
question.
two answers. Yeah. So upgrade itself doesn't matter at all. So basically, upgrade is around the same thing. So basically, you first upgrade and then you rebuild your indexes.
Asynchronously, right? Because we
So
already...
it's two separate things. Problem is that if you have a really heavy workload, you need to do two things after upgrade. You need to rebuild your indexes and you need to collect fresh statistics for upgraded database.
In stages, usually.
Yeah, in stages, and for this database, it would be like slower than with the previous one. But well, I would say you can still do that asynchronously. So most likely your server performance will drop slightly while you would be rebuilding indexes, but it's still worth of it. So I would say the upgrade process is still the same. Then you add this rebuilding, which is asynchronous. If you have a lot of memory on your server, you probably can benefit from concurrent rebuild index concurrently by increasing maintenance work mem.
And also, of course, we can do several in several streams, several
processes.
Yes, it depends on disk I/O, how strong it is on our system. So and here we talked about PG upgrade approach. When we physically upgrade the existing cluster, we don't do dump restore, which can be used only for smaller databases because it takes time.
Yeah.
If we do dump restore, of course, indexes will be recreated because restore will be created from dump. Dump is logical. It's like a set of SQL queries, and create index will create. This feature is enabled by default. This option, as I showed, like it's on by default. So right, yeah, I agree. It should not like it doesn't affect upgrade time, but it means that if we want to benefit from this feature, we need to plan additional steps, post upgrade steps, which may take, depending on database size, may take days actually, right? Because if it's multi-terabyte database, to rebuild many indexes, it's kind of like index maintenance. When we fight with bloat, we use repack or PG repack or reindex, it may take days. So,
and well, in such case, you actually can plan upgrade carefully. So it's generally good practice to plan upgrade carefully. But you can take a look before you're upgrading in this period of time when you plan your upgrade, which queries are in top 10 pgstat statements report, for example. And for those queries, you rebuild indexes first. So it's like there is a lot of room to play with exact scenario for upgrade.
To optimize the process.
To optimize this.
Yeah, I agree. Actually, some people already upgraded to 13 even on production. I saw yesterday on Postgres Slack, which has already more than 9,000 people or so, like insane amount. It's very popular. I saw pictures from monitoring. I cannot find it right now, but if you join Postgres Slack, I can provide link. In general channel, someone yesterday posted a picture showing that after upgrade and rebuilding indexes, CPU utilization dropped significantly. Actually, like it's the same as if we just do index maintenance and rebuild them. But the good thing here, since this deduplication not only reduces size one time, it will be applied for it will mean that we need to do index maintenance much less often, right? So not frequently, because bloat growth will be much slower, right? This is very good feature, and I do like it. And again, if you're interested in details, I already on YouTube video in description you can find link to whole hour video from Anastasia Lubenikov describing all the details in from first hand. Okay, let's talk about vacuum. I already disabled auto vacuum, so we have quite bloated table, right? And this is good for this
for demonstration purposes.
Right. So vacuum got support for parallelized processing, but only for indexes. So not the table, only for indexes. So multiple vacuum workers may be launched to process multiple indexes. Actually, we need to create another index to show it, right? Because otherwise we have only one index, it will not be noticeable. I create several indexes using this idempotent query, not providing name. So now we should have 3 indexes, right? We have 3 indexes here and there. And just let's run vacuum, and with as a parallel, right? Parallel to verbose, something like this. No, vacuum. Okay. Let's see how it will work. In 13, of course, in 12 it's not interesting because parallel does not exist there. But here in 13, we see that it planned. Yeah, I shouldn't do verbose actually. So, and this time I think indexes will be skipped, so we need to scroll up. We see that multiple workers were, sorry about that, it's too many details there. So 2 additional workers in addition to the main one were launched, and one index was, so work was split, right? This is good. And this helps with processing of very large tables, but 2 notes here. First is auto vacuum was not improved, only manual vacuum was improved. And manual vacuum, if we just show vacuum cost, there is delay and limit, right? These 2 things, auto vacuum also has similar options, pair of options, and manual vacuum has a pair of options. And this 0 means that we are not throttled. So when we launch vacuum command, we are not limited in terms of Postgres does not limit itself except naturally, right? No throttling applied, and it's already like full speed. And I usually, like on systems under load, I usually advise to be quite careful with it. Sometimes it's fine because like vacuum algorithm.
You know, you need to know your disks. So basically,
yeah, you need to limits,
you have
right.
proper disks, proper SSDs, which allow you a lot of parallelism, you can actually benefit from this full throttling of auto vacuum or vacuum. And here probably as well, but it's like it's not the production ready advice, because to few experience of Postgres 13 in production, and we'll see like next month if it's a good idea or not on real production cases.
Yeah. So right, auto vacuum is by default limited. It was in Postgres 12. It was improved because before we had like loop cycles 20 milliseconds, and now shorter, 10 times shorter cycles means 10 times more room for like throttling is 10 times higher. And there are some estimates that with 20 milliseconds before Postgres 12, default settings led to like quota, which for reads were roughly 8 megabytes per second. With new quota in Postgres 12, it's like 80 megabytes per second. But manual vacuum is not throttled, and you can see much more disk I/O when you run it. And I usually recommend to put something like 1 millisecond here to at least somehow limit yourself, and if you're running it under load on live system in production. But new feature says, okay, not only we not throttled, but also we can do it in 3 threads. And so it's kind of like, it's interesting. If you don't limit yourself running manual vacuum, you should be very careful watching your disk I/O and how much of it is associated with your manual vacuum. But again, automatic vacuum didn't get it yet, and this is for future. So if you don't run vacuum manually, it should be like you don't care. This is good feature to process large tables much faster, right? Actually, I like it, but I would still put 1 millisecond here and only then run it in parallel, three threads, maybe will more even. So,
and I would say I probably quite welcome this feature, because usually it will get to auto vacuum soon. That means then auto vacuum will learn this. It would be really a huge benefit. Not talking about if auto vacuum is good or bad. It just would be much better to have auto vacuum which can perform good.
Yeah, this raises a lot of emotions in me, because
Yeah.
because auto vacuum defaults are very conservative. Like this was changed from 2022 a year ago. This is very good, like big win, because previous setting, as I remember, the people said it was created like 15 years ago or so. But we have also 2 additional things to take care about. This thing says that auto vacuum is only 3 workers. So we usually tune it if we have like almost 100, almost 200 CPUs. It's insane to think that 3 is enough, right? We're not using this power. We should clean the house much faster, right? Utilizing much more CPUs. And then there is also a scale factor, and this is what I was going to talk about. There is also a scale factor and threshold which apply to deletes and updates. And if we have enough dead tuples, auto vacuum starts to process table and its indexes. But again, defaults are quite conservative. We usually on heavily loaded OLTP systems, we usually make them much more aggressive. For example, saying that you need to process and delete dead tuples after 1% of table changed. But before Postgres 13, these 2 things are new. Before Postgres 13, there was a problem. If you have append-only workload or close to it, and you just insert to table, auto vacuum doesn't care about it. Only when you start deleting or updating, and it looks like no problem, right? Because we don't have anything to delete. But the thing is, auto vacuum has 2 additional purposes. First is to rebuild statistics, and second is what? To update visibility maps. What's that?
Prevent wraparound.
Oh, prevent wraparound is the fourth one. It's very important, but it's not related to. But yeah, maybe it's also related, right? So three things. So a lot of inserts and no updates and deletes can cause 3 things, right? Prevent wraparound is one thing. Second is we need to update statistics if we inserted a lot of data and auto vacuum does not want to process this table. Statistics is outdated and queries are suboptimal. And finally, also important, we need to keep visibility maps in updated state. This is also one of additional tasks auto vacuum does. And this is important to maintain index-only scans in good shape. For example, if you do select count star from table with some query which is supported by index, usually you get index-only scan, and that it's as good. And if visibility maps are fresh, Postgres doesn't look at heap at all. If they are outdated, Postgres doesn't know, since indexes don't contain version information, like which links to go to leave entries in tuple, live entries or dead entries. Visibility maps is needed. Map is needed to understand should we check heap or no. And now we can configure and say that we need to process table and indexes when a lot of inserts are happening. So this is also very useful. And it means that more index-only scans will behave much better with better performance with fewer heap checks. You can see it in explain plan, heap checks some pages. This is good, bad sign if it's much bigger than 0. 0 is the best. Heap check 0 is what we want from index-only scans, but of course it means that we need to be very aggressive in terms of auto vacuum or manual vacuuming. Okay, what else? Very interesting thing. We have not much time left. A very interesting thing is related to plans. Let's see, like indexes also. Let's create another table, another column in this table. Alter table T1, add column. For example, I don't know, like C1. It will be text, and we will fill it somehow, randomly, with some random text. Right? Let's do it. It will take some time, of course, because this is not what you want to do on production, because you are updating whole table here. Okay, and we have this table with 2 columns, and let's drop these indexes, just not to think about them at all. And this one also. Okay, and we will be comparing Postgres 12 and Postgres 13. So we have table with 2 indexes and 1 index and 2 columns, and the index is on the first column. So if we want some query, I will be using. I like this idea to use 13 as a number, because it's Postgres 13. It's from Crunchy, Jonathan Katz's article. So, for example, if we say that we need, let's enable timing. If we need to see first 13 rows from this table, where let's do without where, just order by IC1 limit 13, right? So this is what is happening in Postgres 13, and this is what is happening in Postgres 12, right? And we can see that timing is very different, right? It's very, very different. And in 12, we see dozens of milliseconds, at least 30 something. On Postgres 13, we see less than 1 millisecond. It's very good. Let's understand why it's so. It's so because, let's see, explain analyze with buffers, as I usually do. By the way, there was some discussion to make buffers enabled by default in explain, but unfortunately, Postgres 13 didn't get it. Okay, we see that especially for Postgres 12, timing increased because we have observer effect, and this is what you should expect when you do explain analyze. Timing increased, and the most important thing here, you see thousands of buffers hit in red here for Postgres 12, and just 4 buffer hits for Postgres 13. This is massive change. Why? Because now, if we compare plans directly, in this case, when we want to order by 2 columns, but we have index only on one column index, very simple index, and we want only first several rows until before prior Postgres 13 sequential scan was needed. And right now we have index scan, and then this new type of node in explain plans, incremental sort. And this is so like it feels like so basic thing, right? So how we lived without it? It's like we need it, right? So it means that before Postgres 13, you need to spend more thinking about indexes. And I suspect that you mentioned this, like Django or probably other ORMs frameworks, they tend to suggest to create indexes, like let's create index on each column, right?
Yeah, exactly. That's a very typical approach for actually many people who likes ORM. Even if ORM doesn't create it automatically or doesn't suggest create it automatically, people do that.
Right, and I suspect with this change in Postgres 13, those people will be covered actually better, because if you have indexes, separate indexes on first column and second column, like it won't. Let's check it. Create index on T1, and we named column C1. So second column C1. Let's imagine we have indexes on both columns, right? Instead of two column index. And again, like it's the same. It doesn't help. In Postgres 12, it's sequential scan. In Postgres 13, second index won't be used, right? But also doesn't hurt here. We can use first index. Postgres uses first index and then performs second layer of sorting additionally on top of it.
I would say it probably will hurt you in different other ways, but not in this exactly case.
Yeah, this is
It
a good
will
point.
consume disk. It will consume resources.
Slows down updates.
Slows down updates. And
slows
so on
down.
and so on.
Yeah. Like if you don't have separate queries based on second column, of course, I would recommend to have one single two-column index in any version. It will be faster, right? Even faster than this, because Postgres wouldn't do incremental sort. Of course, if it's just 13 rows, it's very fast. But if it's like 1,000 rows, it's already maybe noticeable. And but if you like, I like this feature anyway. Like it's good. It's good. Like I imagine that we will be thinking, do we really need two-column index or no? Maybe not, because it's bigger, right? Two-column index is bigger than one column. Maybe we don't need it. Also interesting side effect, very positive side effect, that if we don't create two-column index, we create only one-column index, we improve probability of having hot updates in place, because second index is not participating in second column is not participating in indexes. It means that if we update this column, we have hot update, and it's much faster than regular update, right? So it's an interesting trade-off. I think we will be it will be an interesting task what to choose: two-column index which behaves better even without incremental sort, or just one column index, save space and improve update speed. Depends. It depends. Also, it's not obvious to me at this point. We need to gather some experience before we understand how it's working. Okay, so what else? We covered things related to performance. We have just maybe 10 minutes left. Let's talk about observability, because I like it a lot. We like very small but very important changes appeared in Postgres 13 will help with to have better monitoring and to troubleshoot queries better and so on. For example, if we do update here, update T1 set I equals I, where I less than 10, for example, we can see here. Oh, I don't see it. Why? Where are our wall? Right. Yes. Sorry, I forgot. Yes, this is yeah. It's not enabled by default because observer refactor as well, because fears that we don't see it, by the way, here. Timing was even better fluctuations, but anyway, if you want to see wall related data during micro optimization when you analyze a single query, you need to specify it explicitly like buffers. And if you do, you see this, right? So with 1,000 rows, we generated this number of records, 4,000 records, 300,000 bytes roughly, and this is good. And we see it even for each node. This is really cool. So you can understand how specific modification query. Sometimes, by the way, it may happen with select query as well, if we need to update hint bits, right?
Or if you have a stored procedure or something like this.
Well, this is different.
Somewhere
this is
inside the select query.
Yeah, I should say read-only query. Read-only query also may produce some wall data if hint bits should be updated, needs to be updated. But for modification query, of course, it's useful to see how this query is heavy in terms of wall generation, and but we don't want to start here. We need to usually we want to start from very top and to do macro optimization to see the whole picture. For this, we need to usually this is standard de facto create extension pgstat statements. Let's do it. And here, well, I don't care about 12 anymore. Let's see it here. We've got several new columns, but actually two sets of columns: wall and wall records. How many records? How many bytes? And this is full page images. So it's full. When we after our checkpoint, we update anything inside the 8 kilobyte page. Postgres writes whole page to wall. And if new checkpoint happens, again, first update will lead to writing full page to wall. And this is why like very frequent checkpoints hurt performance, because more data should be written to wall. Actually, it's controlled with full page writes. Of course, it's on by default. And on some systems, you may consider turning it off, but usually it's not a good idea if like you need to think twice about it. But if let's do it once again. So we can see in pgstat statements, we can see right now this information aggregated. So, oh, sorry, of course it should be loaded and Postgres should be restarted. Not this time, but we can see in pgstat statements information for each query group, and we can actually aggregate it if we have if we track a lot, like many thousand, for example, more queries in pgstat statements, we can see almost whole picture, and this is very good for top-down analysis. So we start asking why we generate terabyte wall data per day. It's too much. Let's segment per query, and let's localize what kinds of queries produces more wall data. And then we go down, and then we can apply, we can run explain analyze buffers wall on a clone to see what exactly is happening under the hood, right? And this is very, very, very useful, because before Postgres 13, it's a mystery. If you see that a lot of wall data generated, what you can do? You can make checkpoints less frequent if full page writes are turned on default. And you can also compress using wall compression. You can enable compression of those full page inserts.
The possibility is also to figure out which query calls these problems, but it was like usually guesswork by the DBA. So it's
right,
like this addition is
magic.
Very convenient. Yeah, it's not
Black
a magic,
magic,
but well, still to see that in regular performance reports or on monitoring or whatever, then you have this. It's just amazing.
Try to find some correlation and so on. Yeah, it's
it's amazing feature.
Yeah, this is very for observability. It's a very cool feature. And also, pgstat statements got additional set of columns timing. So we can see timing here, right? So we can understand how, like for no exact timing. I mean planning time. So we can split execution timing and planning times and numbers and understand for complex queries. And if you increased default statistics target, for example, you have much more stats, and planning time may be increased, and it may be noticeable if you have very frequent queries. You may be think about tuning it somehow, maybe reducing number of buckets in statistics and so on. So this is very also very useful. And finally, in terms of observability, what I wanted to say, this log how is it called? 1 second. Maybe if there are any questions, I will find this log statement sample rate, right? So this is it. Yeah, right. So this is it. Log statement sample rate appeared in Postgres 12. I remember discussion in Hackers, and that was I raised the question actually that log transaction sample rate also needed, because if we start sampling in logs, sampling of queries, maybe slow queries, maybe all queries, in like under heavy load, maybe we need to log whole transaction and don't limit by duration. Like let's for example, let's log 1% of all queries, but let's decide not per query, but per transaction instead. So if we decided to log transaction, all statements inside transaction will be logged. If we decided not to log transaction, nothing will be logged. This allows us to record in logs to capture 1% or 5% of workload, and later, for example, start replaying it in a lab environment, trying to understand how Postgres behaves under different configuration parameters, or how we can tune it using some changes in index set and so on. So this is for macro optimization, very useful. We can capture only some percentage of all queries, deciding either on statement level or on transaction level. Also, it can be applied not if you want, like if you want to capture all queries, okay, you can do it, but you can also still have some threshold. And where is it? I don't see it. Duration, here it is. So you can also control this threshold and log only queries which are really slow, for example, longer than 100 milliseconds or 500 milliseconds, and still have sampling. This is very useful observability features. I think it will take some time for tool sets to start using, or some monitoring tools to start using them, but eventually we will have this option as an option, and we will see not only PGSL statements but also examples of queries, and we will be able to see whole picture before we start optimizing particular queries, right? So what else? Any questions? Because
yeah, we are close to end. Just to add my 5 cents about the observability, there are lots nice improvements in terms of additions to the PG catalog. So there are lots of things which people who use Postgres were actually struggling with. For example, there is progress of PG-based backup. Some people still use PG-based backup instead of a PG backrest, but for those people that was extremely inconvenient to not have a progress. Now it is in Postgres 13.
Yeah, I forgot to mention that we also in explain we also have better planning information if we do this again. If planning time here, but okay, I need to reconnect actually, right? No, I don't see it because it's Postgres 12. Sorry, I need to reconnect here and do this query once again. Select. Where's my select here? So we have planning here additionally. This is how, like, we see how many buffers we are needed to perform planning. But if we run a second time, it disappears because it's cached in this session. So this is also kind of nice additional piece of information that can be used to understand query better. I also like it. So, okay, any questions? So of course we didn't cover like even half of it. It's much more, right? So, but I hope it was useful. we can, like 5 minutes or so, we can talk about something else if there are any questions.
Yeah, and in general, it would be a nice addition if we need to cover more DBA stuff, or we need to cover more developer stuff. Because, for example, Russian language version this season is mostly oriented on developers, because previous season was more on DBAs. And
well, maybe
we can try. We can try.
Yeah, it's of course functions overlap here. Like who does need to rebuild indexes? Maybe DBAs, right? But that indexes behave as we showed better. It's also good for when you develop something and plan performance and so on. But features, of course, a new feature that allows you to verify, to see progress of base backup and to verify base backup. This is, of course, very good DBA feature, right? For administration, very cool feature. To see progress and to verify backups. Okay, so if no questions, I think that's it. Thank you so much. It was our first try to run this session in English. I hope we will have it regularly, and we will be moving to separate channel, and actually it's already working, Postgres.tv. I like domain names, so Postgres.tv will lead you to new YouTube channel. You can subscribe right now, and this video will be re-uploaded there as well, and new English sessions will be on that channel. We will try to invite interesting guests and do more hands-on sessions and so on. So thank you for watching. Don't forget to like and to leave some comments if you have questions.
Or leave your useful feedback. That's always welcome.
Yes, thank